Hello everyone, welcome to the second part of data wrangling. In this video, I'll discuss how we handle duplicates and flat and nested JSON data. So let's get started. So duplicates are a common challenge when working with data sets, and handling them correctly is crucial. Sometimes duplicates are necessary, but other times they're just redundant entries that need to be cleaned. So first, we need to identify which records are duplicates, right? So first step is identify. Now, this can be tricky because you can have different levels of similarity. For example, we can have exact duplicates like identical rows. Then we can have partial duplicates where some columns have duplicates while others may differ. And the third is near duplicates. You would see that they are not completely identical and there are minor differences. Along with this, it is important to then analyze why and how duplicates are there in data set. Let me show you something. So you see, this is what I was talking about, identifying duplicates. The first one that I told you guys about, exact duplicates. So you see the row 1 and row 2, right? It is completely, exactly matching the row 1 and row 2. So this comes under exact duplicates. Then you have your partial duplicate, right? Where you have row 1 and row 2, where you would see column 1, column 2 are similar, but just one, you know, value in second row is different. So this makes it a partial duplicate. Then comes the near duplicates. Okay, you would see that the column 1 ID and column age, they're similar, and the name column you would see, name Krishna and then K. So you are seeing that there is a minor name difference, and this is considered as near duplicates. Now, so our first step was to identify duplicates, the type of duplicate it is. Okay, let's consider this step one. And the second step is to analyze duplicates. Okay, so why it is important to analyze duplicates, right? So it is important to analyze why and how duplicates are there in the data set, right? For example, we can have duplicates due to data entry errors or data integration issues, right? Or also the way we are conducting our data collection methods. And at the same time, there are possibilities that these duplicates are intentional and meaningful for our dataset. So, for example, if you have multiple financial transactions, or if you are recording any measurement or valid variation recordings, then these are meaningful duplicates. You need not go ahead and work on them actually, right? Now, why it is important to analyze duplicates? So let's say if there are duplicates in the data set due to our integration issues, how we have merged the data from different sources, right? And then we are getting duplicates, right? Then it is something wrong, right? Which we do not want. So we can keep a check on that. We can improve our data integration. We can improve the way we are merging our data from different sources, right? And we can make sure that the next time we are running a process of data integration, right, these things do not occur. Okay, and another reason why you need to analyze is, so as I discussed, as I told you, that there can be times when the duplicates are actually meaningful. So when you analyze and you find out that those duplicates or that data is actually meaningful, so you can make sure that in the next process of your analysis or data wrangling, right, these rows are not removed because those duplicates are actually helpful, right? If if you're going to go ahead and remove them, then it will be a loss of data for you, right? So this was about identifying duplicates and then analyzing duplicates, right? Now let me show you some other things. All right. So let us now talk about how we can actually find out duplicates in our data, right? So for this, I'm just gonna go ahead and create a data set for you, right? I'm not gonna export it from any file. For the learning purpose, I'm just gonna go ahead and create a data set. All right. So yes, uh, import pandas as PD, and this is a data set that I have created, small sample, right? And then I'm just gonna run this, and then run this, and we'll see our data. Okay, this is the data. All right, and now we will actually see how we can find the duplicates. Okay, now if you look at the data that I have over here, okay, so you would see that most of them, the name or the email, right? They are all kind of name specialists. So many duplicates that we have over here, along with emails, we have duplicates. Issue description, uh, you know, they are in different sentences, but they all mean the same, right? If you see, login is not working for me. Yeah. We have most of them the same thing, right? I'm unable to log in into my account. I can't log into my account, right? So all these things. So now let's start with, if I run, okay, all of them are showing false, right? So I went ahead, ran this dot duplicated, and though we discussed that we have duplicates in the name, the email, leave about the description for now, right? So at least for those it should have shown true, but interestingly it will show all false, right? And why is that? Whereas we do know what duplicates. So that is because, see, I'm seeing duplicates on the basis of you know this column, the customer name column, email column, right? But thing is that if you check ticket ID name, ticket ID and the name over here, and then you see the the description. So the whole row is actually unique. If you see this first row and then this row, you would see the row is actually unique due to different ticket ID, different description, and different date, right? So that is the reason I'm getting false over here, right? So it's not that really helpful, isn't it? But if I go ahead and let's say run, I use subset, okay? Subset as in I use a particular column. So it's the column here, customer name, right? Okay. And this parameter, I'll tell you what this parameter is, key parameter. Let's run this first. Now we are getting what we want to see. Okay. You see, everything was false over here, and you have true. That means this is duplicate, 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 except these three. Just a moment. Let me just comment it out. Don't need this. Now, you see, first one tells it's a duplicate. It is. Now, let's check for the name Rohit. Okay. Do we see Rohit anywhere else? No, we don't. So it's not a duplicate. No Sneha and no Rohan. But apart from these three names, every other name is a duplicate, right? Now, this was because I gave keep, right, the keep parameter as false. Now, what is this, keep parameter, right? To show you, we have got things. I'll explain what these three mean. Okay, so in case of duplicated, okay, when we are using this, all right. So in this, you know, it, the keep can have three values as you can see, right? False, first, and last. Okay, so keep parameter when with false, it marks all duplicates and gives us the result. Okay, so like here, it gave us all the duplicates. Okay, and when keep is first, right, it marks all duplicates except the first occurrence as true, right? Except the first occurrence. Now, if I go ahead and just change it to first, okay, and then just run. So we know Aman is, duplicate the first row, but it's gonna show false. But it's gonna show true for this fourth one. Why? Because, as I said, it will mark all duplicates except the first occurrence. So the second occurrence onwards, everything's gonna be true, right? Now coming to the last, okay, let's type this. And the second one. Now, even with the last, okay, value, it's gonna mark all the rows duplicates except the last occurrence, right? So if I go ahead and change it to last over here, you would see this would become true, right? And the last, let's say for a month, if this is the last, okay, then this would be false. Okay, see, so yeah, this is how it works. All right, so I believe we are clear till here. You know, keep first, keep last, okay, and then if we do not wish to see uh, you know the duplicates in the form of true or false or in terms of boolean, we can also go ahead and use group by to actually see how many number of duplicate count is there for a value. For example, if I want to see duplicate count of customer name, for example for this name, how many duplicates are there, then I can just go ahead and use group by. Okay, so let me just show you. and it'll give you how many duplicates are there for this name. Okay, and for the ones chose one, that means they are not duplicates. These names do not have any duplicates. We can also check with order ID. So with order ID, what we can do is, let's say if I there's so for this order there are already two tickets created. Okay, so I can just go ahead and remove one, right? Because you know it's the same. I'm unable to log into my account, so I can just go ahead and remove one. I can keep the latest one. Let's say I'll keep the one, and I'll remove the older one. All right. So in this way, we can sort our data. We can just remove the unnecessary or the redundant data and have a clean data so that we can work on it. It will also improve our efficiency in that case, right? All right. So we did see how we can find results of exact duplicates. So till now, what we were seeing was all about exact duplicates. But as we discussed that we have partial duplicates and near duplicates as well, right? So what about them? How are we going to work on these two type of duplicates? So till now, what we discussed was very basic command that we use. Now I'll show you something a little advanced, right? So we'll go ahead and I'm going to use a simple ticketing data set, which is similar to the data set that I used to work at my workplace, and it's just a sample. I'll attach the file in the GitHub link, right? And we'll work on it, right? Just give me a quick moment as I load that particular data set. All right, so I have loaded my data over here, and when I run this is what I get: date, source. So this is more of how your Salesforce ticketing data would look like after cleaning everything. So I've just taken out a sample, how it used to look. Description, you would see over here that in till customer ID, right, most of them are exact duplicates that you might find. For example, this and this two over here. But sometimes what can happen, the contact name, let's say um, Mike Wayne and Mike Kelly. Okay, so let's say Mike Wayne is the actual customer, and you saved, it's actually Kelly who called, but you saved the name as Mike Kelly, right? Let's assume that Kelly is wife of Mike, right? So in that case, but you save the name as Mike Kelly, and the customer ID is also same, but the email address is, this could be Kelly's email address, this could be just Mike's email address. So in this case, they are not exact duplicates, but over here they are. But when you come to the contact name, you would see that they are near duplicates, right? And again, if you run df.duplicated as I showed you, you will not find any of them duplicated, right? Because again, ticket ID is different. The issue is, if you see, is kind of simple, right? The issue, the product that they have issue with is also similar, right? Then description, again, uh, it looks different, but at the end, they both kind of mean the same. The issue is same, right? So now to work on near duplicates, right? We have got a wonderful library, and we have got alternatives, many alternatives. So I'm gonna start with a basic one, and then I'll show you the alternatives of it. right? So yeah, yes. So as I was talking about, so we'll discuss about from the basic library, and we'll go on to the advanced libraries, how we can find the new duplicates. So the first one is, call it Fuzzy Wuzzy, right? That's a library name, and I'll just show you how it works. So let's go. Okay. Um, just give me a minute. So if you do not have it, because I do not use Jupyter, I most of the time use Google Colab because it's easy and just for quick learning, it helps me. So I might be having this library in Google Colab, right? So no worries, you can install, you know, if whatever you're using, Jupyter, you know, Google Colab or PyCharm, you know, Py, anything, then you can just install it this way. Let's just give it a moment and it should be done. All right, it's done. And great. Let's comment it out. This is our library, fuzzy wuzzy, and import first. And then there's okay. You can ignore this one, no problem. And just to show you guys how you can actually use this and what's the basic syntax, I'm just gonna show you. Let's say for the near duplicates is, let's say it's actually the basic syntax for this is that I'm going to use right now. Let's say if I give the string values, okay, my name, and this should give me the score, the similarity score, right? Or you can say the ratio, right? How similar the two given strings are, right? And if let's say if I give over here 72, okay, 77, about this. Pretty close. Okay. So looks like it does work well, right? And we'll work on this. Just that we will not be using Fuzzy Wuzzy because Fuzzy Wuzzy is now an old library and is pretty depreciated and outdated. So you know, lately the one that is being used in the industry is Rapidfuzz, which is new library but is based on same API as Fuzzy Wuzzy, right? And the only thing is Rapidfuzz is little fast and more accurate. So I will demonstrate few lines of code so that we can get idea how this actually works, right? So I'm just going to work on this same data set that I have loaded, you know, df underscore ct, and we'll try to work on it and see how this looks. So let me just go ahead and demonstrate how we can go ahead and use Rapidfuzz. Let me just comment on this. Yes, I will need to install Rapidfuzz as well. While it's taking time, let me just go ahead and run another lines. Perfect, it's done. Okay, then I'm gonna do is comment this out, copy, run, done, and I'm gonna start writing my code from this section. So this gonna be little complicated. We'll have loops and we'll need to manually append the data. So yes, just stick on. It'll take a minute or two for me to just write the code. And I'll just explain you as well. This is a function that we are creating, and just gonna go ahead and kind of, you can give, this is basically the data set. Okay, you can put it as df or anything. I'm just gonna go ahead and use dfct because that's what the name that I gave to my data set, the column. Okay, so when you are at the end calling this function, okay, you need to give the column name, right? So I'm just gonna go ahead, put it to 70 for now. Okay, so in the end you would see something very interesting, right? We are creating an empty list, right? We are creating our first loop, and then we are creating our second loop. Obviously we cannot go ahead and keep I over here, and you must be thinking, why are we using second loop? And that is because we need to do comparison over here, and obviously we cannot compare a row to itself, right? So we need a second loop with the iteration I plus 1, right? So that's the reason you need to have a second loop with iteration I plus 1. All right, now comes the next step, that is the fuzz dot ratio, right? So I'm just gonna assign it to a variable, similarity equals to fuzz dot ratio as we discussed, and in this we are gonna have the first value of column and then the next value of the column, right? So then our, yep, so we're talking about this threshold over here, right? Then we're gonna append the data. Now, how are we going to append our data? Depending on what, right? So for now, I am taking ticket ID, okay? But we can definitely go ahead and change it later, right? Just to demonstrate, I'm going ahead with the ticket ID right now because that's pretty unique, over here, right? For every ticket raised, whether be it from the same customer, same region, different email address, whatever it is, right? The ticket ID is unique. I'm just gonna go ahead and stick to ticket ID and use that. Then, all right, this was the first half. Now, I'm just gonna let it be here and use this section. Yep. And this is I am calling function. I'm basically assigning this function to near duplicates. Okay. So this is our data set. Okay. And now depend on us, right, what we want to give as a column for it to check. Okay. So for now, I'm just going to give contact name. Okay. Let's see. Threshold. I'm just gonna go ahead give 70 again. All right. And in the end, what I can do is, yes, let's just go ahead. All right. Good. Did I miss on anything? Oh, oh, oh. Yep. Excuse this. All right. Let's. What did I miss? Oh, okay. All right. Cool. Name duplicate is not defined. Let's see. Did I miss over here? Okay. I miss on anything? Just a moment. All right. So the issue was what the mistake that I was doing was, here I had just given duplicate instead of duplicates. And again, if you have seen my previous video, I keep doing this mistake. I keep writing the column names incorrectly. So I had given ticket underscore ID, where it was just ticket ID. And one more mistake I did not see that, parenthesis. I had just given one set of parentheses, whereas, append if you give just one set of parentheses and you have passed three arguments or three parameters, then it will throw an error, right? So you need to give another set of parentheses for this, right? And when you run this and then this and ticket, you know, this, so it'll tell you how similar, the two tickets are. So let's go ahead and check, because I have given the threshold as 70. So let's see, just give me one moment. 201 and 205. 201, 205. So we had gone ahead and done this on the basis of contact name, right? See, Jonathan Han and Jonathan H, right? So gives us a similarity of 90% for the two. Okay, and another one that we had, 14 and 15. It missed out on this one, Grand Power and Netherlands Power. So 74%. So if I do it 80, then most probably it will just give me one, you know, so line, or the 201 and 205 as 90% similarity. So this was on the basis of contact name. What about if we take something else, right? And then we can check. Okay, so let's go ahead and take issue, and we'll do it. We'll compare the duplicates used, by keeping issue in mind. Okay, just gonna change this to issue 5 and yep, issue, right. Okay, 207 and 212. And 212 is also banner. No, I'm so sorry. 207 is production issue, and this is production loss. Okay, so it's giving 80% similar for that. Okay, and do we have anything else to check with? Let's go ahead and give a try to, let's change this value to 60 and see how it looks. All right, 202 and 210. 202 is Wi-Fi issue, 210 is login issue. Gives a similarity of 66%. Just because of the last word having issue, it's considering these to be similar, but they are actually different. Okay, got it. And let's try with contact, contact. You see, the space is the mistake I keep doing. Whoa. Let's increase the threshold value and just check. 208 and 212, they are 82. And first of all, no, I do not want to see those many uh, values. So I should have done this before. There we go, 82.76. Need not see those many numbers after the decimal point. 208 and 212. 208 and 212. Mike at Yahoo and Kevin at Yahoo. Okay, just because of the Yahoo, it's showing that these two are what, 82.76% similar. Okay. What about we go ahead and just change this to customer ID and on this. Okay. ID to 1 and to 5. 5. It's from the same customer. So, yeah, okay. Got 10 and 230. 80% similar, but they are definitely different people, different contacts. Okay. So I believe the best way to do this is either use the contact name or the contact or the issue. I believe even the issue, if because I have maybe not created the data set accordingly, I could have, because if you work in real time, you would see that you will have limited issues, right? Let's say you have 10 issues, and these will be between, from 1 to 10, whatever the issue is, it's gonna be that. So, but I believe, going ahead with the contact name and the contact, you should be able to find out the similarity or the near duplicates. So yeah, that's what. So basically, it looks like the actual full name is Jonathan Han, but there was some typo error or something like that. So the last name was just left with a letter H and was not completely covered. So yeah, the typo errors or those things that we need to keep a check. All right. So this was all about uh, how we can check the similarity, right? And apart from this uh, fuzzy wuzzy, right, or the rapid fuzz, right? So I'll show you few more libraries that can come to help, right? So we will be discussing about library called record linkage. Right now, record linkage is not the favorites, right? It's not that great as Rapidfuzz, but can be used sometimes to get some idea on record deduplication. Also, if you want, to avoid these, manual looping and appending of data, because these can, complicate uh, our work, right? So you can go ahead with record linkage, very limited of coding work. But however, for more accurate results, there are other alternatives as well. So let's say a data scientist would most probably go ahead with a machine learning based approach rather than going ahead with rapid first or record linkage, ML based approach where you have the cosine similarity and stuff like that. So, we will not go deep dive into that because that's again too deep, right? So I'll show you how record linkage works and how you can understand the data or find the near duplicates through that, right? All right, guys. So I have installed record linkage and I have imported it and I have wrote down the code already just to save some time, right? And then yes, first step is to set up an indexer, right? So if you go ahead, this is by default going to be the same for every data that you're going to do. Let's say if you have two data sets, you can just go ahead, give one data set, and you can go ahead and give another data set like this, and then you can compare it. Okay. Now this indexer.fill is used because, to compare every record with other record, right? So this is also important, right? So these three lines of code is going to be the same for every time you're using this record linkage, right? Then coming to this point, you have, compare record linkage dot compare. Okay, this is a function. Even this is a function. So whenever you're writing this, make sure that the I and the C is capital, or else it's gonna throw an error. Okay, Now, once you do this, after that, you have these three lines of code: the string, the string, the string, the exact. So in this, you will pass the column names that you want to use and the method. There are two methods, Winkler and Levenstein. I'm not going in depth about this because there is a lot more to discover or explore when it comes to these methods, right? So what the maximum we can do is we can just go ahead and make changes or tweaks so that we can get our output accordingly, right? So this is one method and Levenstein is one method, and I have used this for name, and for email address I have used Levenstein. There is no compulsion that for emails you need to use Levenstein or Winkler. You can use any of the methods, and then you can check how your output looks like. Okay, after this, once you have you compute your this value with your data set, and then potential duplicates, and then you print it. Now this value is key over here, so I am expecting at least one duplicate over here. Okay, so if you see 2 1, record 2 and record 1 has a name similarity of 1. So let's see our record 2, right? You see Mike, Wayne, Mike, Kelly. Okay, but their email is not. Then 4 and 0, Jonathan Han and Jonathan. So ideally, it should give me, a value between 0 and 1. 1 determines 100% match, which it is not, as we can see from our data set. So it looks like there is some changes that we need to do, and we will look into that. There are a few tweaks that we might need to do. And now when I change it to 2 over here, that means at least two columns I need to have with this, similarity, or this, or should be exact match. So if I go ahead and do this, name similarity and email similarity, both are 1, and that is for record 4 and 0. This one and this one. So this is how our record linkage works. Okay, yeah, we may need to do some tweaks and changes, as I told you that I'm getting exact similarity of 100%, and ideally should give me result between 0 to 1. Maybe this is because of the data set that I have, but yes, in short, it does need few tweaks and changes. All right, let's not divert from the topic. And yes, this was about finding similarity between your duplicates. Uh, this was just to show you how you can actually run the commands and find the duplicates, right? Now coming to the point, which is removal of duplicates. Now, easiest way to remove duplicates is using, drop duplicates command. But again, it may not drop duplicates because, as I mentioned earlier, it is checking by rows, and if rows is unique, it will not detect them as duplicates. So let's go to our first data set that we had created, and let's work on that. Let me just add a few spaces over here. Okay, right, let's go. And if this is df, and if I go ahead, use just a moment, and then if I run this, it's giving an error. Oh, my bad. So we had like 20 rows over here, and none of them has been dropped because yes, uh, because of unique rows, it will not consider them as duplicates, right? So again, if I need to drop them, what I can do is I can use a subset, okay, and I can give the column name, you know. So, for example, go ahead. Uh, I want to show you this way. Now, again, even over here we have got, the key parameter, okay. So, and this is gonna be first, this is gonna be last. So again, it means the same. So this value over here, okay, will remove all duplicates from column except first occurrence, right? That means this is gonna stay, but this will get dropped. This is gonna stay, and these two names will get dropped, right? And for the last, again, it means that the last occurrence is gonna stay and the first one will be removed. So this will stay and this will get removed because this is the last occurrence and this is going to exist and this will stay. So if you guys remember, initially I had told that, uh, with the order ID. So let's say order 001 has two rows or two entries. So if I want to keep one with the latest date, I can keep this. I can use the last, and I can, this would stay and this one would get removed. So that's how this keep is important over here. So if I run this, all three of them together, and then this one will be one, it, you know, it has moved all the duplicates, irrespective of whether it's the first occurrence or the last occurrence. So only three unique, you know, entries that we have is these three. So even here we had checked, you know, uh, because we are doing it with names. So Rohan, Rohit, and Sneha. These three are the unique ones, right? Keeps only the first occurrence and remove the others. And that's how you can go ahead and remove the duplicates. So this was all about handling duplicates. There are few more things that we can cover, like merging duplicates or flagging duplicates, but let's keep them up for next time, okay? Because now in next video uh, we will discuss about flattening of nested JSON data. All right. So all right, guys, that's pretty much for today, and in this video, we have covered how to handle the duplicates, how we start with identifying them, then analyzing them, and then actually checking in our data set to find the duplicates, and then not just with the exact duplicates, how we can work with the near or partial duplicates, and then when we find them, how can we remove them. So, all right, let's see you in the next video.